part 3 in the series, The Ancient Legacy, and I just want to recap some details and also correct a couple of details where I misspoke in the video. And so the premise was, firstly, let's begin. So what we have is two pendulums, and we have one which is exactly 1 meter, and that set in 30 degrees, and that section of arc 30 degrees, of course, being very important in the location of Heliopolis, and the three Great Pyramids of Giza actually, as a recent survey showed, are actually pointed at Heliopolis. But that section of arc creates one Egyptian royal cubit. So we have the 1 meter pendulum, which makes 1 second 86,400 seconds per day. Now that same cubit is what defines the dimensions of the red pyramid, as well as the bent pyramid, as well as others. So that's why this particular cubit is so, and the meter, the second, 1 second, 1 meter, 1 cubit, 30 degrees, and the Great Pyramid is pi kilometers south of 30 degrees, coincidentally, which is another interesting factor as well. But also, what I revealed in the last video was how the Indus or Sumerian foot, or the yard, or the wand, the Saxon wand as it was called, creates this cubit which is slightly longer, 3 millimeters longer, and that's about a grain of rice. But that, of course, does connect to the Great Pyramid. Now, in previous videos I've shown this, and what I'm saying is that the pyramid is firstly three-dimensional object. It's not a circle and a triangle, it's three-dimensional. If you look at it that way, you can extract some important information that is otherwise been missed. And also, so what we have here is a map. So what I'm saying is the southeastern corner represents perfect proportions, and we have phi squared, phi and pi, and I'm just going to focus on pi for the moment. But as we move around, so this corner, the southwestern corner, represents measurement, and what we have is a reoccurring, we see pi and phi squared will appear as measurement. And then as we move around, we go from 2D to 3D geometry, and so the northwestern corner represents geometry, and as we move around, the northeastern corner is representation of astronomy, and more particularly time, for instance, 86,400 seconds per day. Now the reason I have this that drawing at, I've messed that up, okay. The reason I have this drawing at 7 o'clock is because 7 o'clock is, well, the 7 is 210 degrees, or 756,000 seconds. Now, I'll leave those two who are familiar with that number on the importance of that. But what we have here is a map, and that the slight variations on each side of the pyramid are actually delivering us some information. And the usual diagrams, okay, so so the typical diagram of a Great Pyramid, and brings forth, again, beautiful information. I'm not dismissing it, but I think there's much better to look at it three-dimensionally rather than has this two-dimensional drawing shows. Now, we don't actually get perfect phi, we don't get perfect pi or perfect phi. We get an excellent approximation, but each base of the pyramid is slightly different from 440 Egyptian royal cubits. There are ever so slight variations, but they are important because if we, again, I'm using the J.H. Cole survey, the Petrie survey, and the Lerner survey from 1981, basically backed up these measurements. And you see, like, there's a slight variation on each side of a pyramid. So it's 756 and a fraction, and here it's 755 and just short of a fraction of 756. So if we take those into account, and if we look at the pyramid as a three-dimensional object, so for instance, this two-dimensional diagram gives us a nice representation of pi. However, if we look at it as three-dimensional, and so here I'm beginning with, and I'm using the ideal measures. So if you look at it from the south, we look at it from any corner using the ideal measurements. That's 880 Royal Egyptian cubits over 280, which brings us to 22/7, which is a very, very good approximation of phi. However, if we use the southeastern measurements from the survey, what we get is it comes even closer. So we get and again within acceptable margins of error of the measurements, possibly could be perfect. But again, I'm sticking to the best surveys. Now, another point to remember is that everything that's shown on the outside of a pyramid is repeated on the inside, and by that I mean the Grand Gallery, often quoted as exactly 151 feet. Other surveys show it's a slight fraction over, and that's important because if you multiply that by pi, we get the height of the pyramid. So the proportion seen on the outside is repeated by proportions on the inside, and this is a recurring theme. And again, it's based on a three-dimensional view of it. Now, I said that the southeastern corner represents proportion, and now I have this ruler here to represent measurement. And as an example, so here we see the west and the south base, and we minus the height, we get 314.17071 meters, which again is a really close to pi and times 100 meters. However, again, within variations that could actually even be closer, but sticking strictly to the J.H. Cole survey. But whatever's on the outside, so we have meters and a representation of pi times 100. Well, we see that repeated again in inside. So in the King's Chamber, pi times 10 meters, or 600 Egyptian royal cubits, or 60 Egyptian royal cubits. And again, I'm going through these quickly. I've done longer videos where I go into more detail, but just as an example of the importance of looking at the Great Pyramid as a three-dimensional object and what will start to emerge from there. So we have the southeastern corner representing proportion, the southwestern corner representing measures. And as we'll see, the western side is measure orientated and the eastern side is proportion orientated. And again, that will connect back to meters. So we've already seen how pi, how meters is now again in regards to, so this the convergence of meters and the second, and with Egyptian royal cubits is again a measurable thing. So now the southwest represents meters through pi and phi. The southeast represents proportions through pi and phi, but that's not for this particular presentation. Well, that's important because as we look at the pyramid from the, now I might have misspoke in the last video, but in the previous ones so what we have is on the northeast corner, if we include the sockets, that these at the corner of each pyramid, and if we include the paving stones, the socle, which gives us the extra height and extra width, what we have is as good as a measurement of the Earth, according to even the best modern surveys. And so for instance, if I'm standing here at the northeast corner, the maximum visible base, what I can see, including the sockets, is the rotational speed of the Earth per second. Therefore, if you multiply it by 86,400, or the height by 86,400, we get a representation, a scale model of the Earth, which brings us back to this 1 meter pendulum, which describes the Egyptian royal cubit, which describes 86,400 seconds per day. Now, after must say the Egyptians understood the 365.25 days per year. So one of the criticisms might be, well, they knew 43,000 seconds per day and 43,000 seconds per night, and that somehow these were separate. Well, they understood the cycle of the sun setting and the sun rising, creating a full cycle. So we now still separate day and night, but the concept of a whole day, including a day and a night, is also within those descriptions. And so the Egyptians didn't, they described a 365 day year, which even carried through to Cleopatra teaching the Romans how to do this. So they did not have a 730 day and night year. It was 365. So this 43,200 seconds per day, 43,200 seconds per night. I don't think that's an authentic argument. It's more trying to fit something in to protect the narrative. And so 86,400 does describe the Earth, and it describes it in a much more elegant way because we don't have to use a top view and a side view. And the 43,200 model is a half Earth representation. And so it's like, it's half a day, half a night, or half the Earth. Yeah. So that's one of it. But what also I showed in the previous episode was that this same pendulum created by the Indus or the Sumerian scale, which is ever so slightly longer, it creates, let's call that the Egyptian royal cubit plus 3 millimeters. Let's call that the Indus or Sumerian royal cubit. And the Indus Sumerian royal cubit, which creates also a second. Now, pendulums change as we move north or south of the equator, so this Indus pendulum is still a very, very accurate one, probably even depending on the location we could also harness in. But if we include, so again, now we're looking from the northwest corner. I misspoke last time and said it's the northeast corner. It's actually the northwest. And this Indus Sumerian cubit describes the base of the Great Pyramid, now including the sockets. The Egyptian royal cubit times 440 describes the pyramid itself. So 440 royal cubits is the base length of the Great Pyramid, as where 440 Indus Sumerian pendulum cubits describes the base of the pyramid, including the sockets. However, it also matches up because it also, on that same corner, we see so 3D and 2D geometry. We see the proportions of a circle inside a square area, two-dimensional, and we also get the proportion of a sphere in a cube. Two-dimensional circle in a two-dimensional square, three-dimensional sphere in a three-dimensional cube, and that proportion, of course, also matches the Egyptian royal. Now I've rounded it off to 5.236 meters. It's 5.2399 something something, but it's essentially as good as what you're going to get. And so what we have now is the Indus or the Mohenjo-Daro and the Sumerian scales matching up with the Egyptian royal cubit there. And we also have a further explanation of why this three-dimensional thinking of a three-dimensional object will actually start to bring a whole lot more information, as where the 43,200 model is quite not quite limited. It's still very good, but what I'm saying is that clearly this is a more elegant one. I know it's gonna have to, some ideas are going to have to be reformed around this, but here's the data, and this is why it's so important. Now, there's a lot more to it because I already mentioned Mohenjo-Daro and the Sumerians. Well, if we go to the Sumerian Epic of Gilgamesh, and what do we have? 86,400 describing the cube from tablet 11. So the flood story, the Epic of Gilgamesh, and we have 86,400, the same proportion of the Great Pyramid. Even in later in New Jerusalem, how 86,000 for Sumerian Royal Babylonian, the same measure where we got these Indus scales, also breaks down to 864,000. And what's the total surface area? 864,000, the same number again. So what we see here, for instance, well, again, 864 connecting to New Jerusalem, but that's an interesting aspect of, but that's really just a follow-on of this earlier Sumerian legend of the Epic of Gilgamesh, the Preserver of Life, or Ark of Utnapishtim, which again has much more information, very beautiful information connected throughout the rest of the tablet, which will bring us back to this number. But we do see how important it is to the Sumerians as well, and the Vapara Yuga, 86,400 years as well. But so where did these Hindu scripts come from? Most likely from an extension of Mohenjo-Daro, but that's a bit of a question mark there, but still interesting. Now, there are other yugas that are 432, which would extend to that 43,200 year argument, but there's also 1728 and 1296, and so again that on its own doesn't really strengthen that 43,200 argument unless you want to be rigid to it, selective about it. But so the cubit, Sumerians, the Indus, but they also, of course, and again in the previous episode I dropped a bunch of links to show how even this Sumerian, Babylonian weight units correspond to this, but without going into the long details of that, I'll do that in the future, but there are sources and citations from in part 2. But we saw again the 27.3 reflected in both the Indus and the Egyptian copper Deben. And in the previous episode I touched on some of the importance of 27.3, 273, and in an earlier upload about global sites all across the world, how they have the same unit, especially for instance 82 feet or 27.33 yards. So in astronomy, in weights and measures, this number is very, very important, and it's again in the symphony of coincidence. It's well, it's a bit of a beautiful thing that they just happen to harmonize on this particular set of numbers, which will also correspond wonderfully to 86,400. And again, always the vesica, everything. The vesica is just awesome. Even the pendulum unit we can get from there, and that's one of the reasons why it's really, really cool. But staying on 86,864, and again, so if we so this was based on the 1 meter pendulum being a unit of time as much as length, and the 86,400 seconds per day, doing away with its 43,200 because it connects so much, not just in Egypt itself, but also with the contemporary civilizations in the Indus and Sumeria. But of course 86,400 seconds per day being the orbital speed of the Earth in kilometers per day. Lovely, lovely tie-in, the meter being the essence of this. And of course the Sun, 86,400 miles. Now the mile, even the E-1 being how many feet there are in an Egyptian royal cubit, which corresponds again to the pendulum, and these very important mathematics. And for instance, that E-1, as Alan Green has pointed out, is also as a proportion built into the pyramid, not just in the cubit, which reflects with the meter and the second and 86,400, but even as a proportion of the pyramid. Whatever is represented in measurement is also represented in proportions in the pyramid. What's on the inside is what's on the outside. There's always a double aspect to remove any possibility of coincidence. But Jupiter being 1/10 of the Sun, mean diameter, average diameter, 86,400 miles again. But also Saturn, and I showed in the last video how it's tilted at 27.3 degrees, which corresponds with the sidereal day month of 27.3 days, which time the Earth travels through 27.3 degrees of its solar arc, or of its journey around the Earth. But again, 864,000 kilometers per day, the orbital speed of Saturn. So even the tilt of Saturn, the angle of the Earth during the 27.3 days of the Moon sidereal orbit, which brings us back to 86,400. Even the, well again I'll show later, because these are 864,000 miles being the Moon diameter, 86,400 miles being the diameter of Jupiter. Now these are both based on, because they're gas giants, and again they're just like the Earth, they're slightly flattened at the top. And what this will actually mean, so if you're interested and just want to have a bit of fun with a calculator, if that's the diameter, multiply that by pi, you get the circumference. And I might as well show that, and these are working off means, but anyway, do that, because I'll go to that in the next thing, because it's, but you're going to get to 273 again, but I'll go into that more. This was more just a recap of where I've been in this particular series, some of the other important coincidences that those numbers of the pyramid proportions also blend with the Sumerians and the Hindus, which, you know, where did the Pakistan and India, the Mohenjo-Daro Indus civilization, how that carried on, and well, of course, 86,400 seconds per day, Greenwich Observatory, which is 51 degrees 28 minutes north within this sliver of the angle of the Great Pyramid itself, which would give even put it at phi proportions. But what you'll also notice is that between 51 and 52 degrees, so right in this chunky little section here, that you'll find places like the Rollright Stone, Stonehenge, Hurler Stones, and amongst others, some really important ancient sites which incorporate this same knowledge, and I'll get to that in the future. I already did a recent upload on how sites all across the world tend to have the same set of measurements built into them, which again will bring us back to these very important numbers in geometry and ancient legends and proportion, including, of course, 864. So we go back to the pyramid, and so this is just what we have is, if we look at the pyramid as three-dimensional, and we incorporate the units and how they were developed from a pendulum, and that each corner represents something. And if you look at it as a two-dimensional object rather than the three-dimensional, using this pendulum, of course, which again corresponds to so many other aspects, and that each corner begins to represent something on its own. So the northeast corner, we have astronomical information, and there's more to come in regards to each of these aspects and why it's so important. The southeast corner brings us proportions, and again, the proportions that are on the outside of the pyramid also will be repeated on the inside of the pyramid, a double reference. And while I'm here, so even the units of measurement, I'll get to more, but for instance, just the base, and I'll explore that more in future, because that's the one-dimensional unit of measure to describe the one-dimensional base. Also converts to this, the Cremona scale converts to 864, something I've done quite a bit on in other videos, on how architecture around the world, sacred architecture, by that I mean cathedrals, major public buildings, are not only using this Cremona scale, which I suggest is actually the ancient Corinthian scale, but also how 756 feet converts to 86,864 Cremona span. But the Royal Mile, 756,000 Royal Miles is the diameter of the Sun. 864,000 miles is the diameter of the Sun, which is one of the reasons why at the start I mentioned 7 on the clock is 210 degrees, or 756,000 seconds. 8 o'clock that's 240 degrees, and that of course is the same 240 degrees we get in the Vesica, which brings us to 86,400 seconds, and that of course is also reflected in the Sun and even the orbital speed of Saturn. And so a lot of these observations for instance, the Greeks, using some very simple techniques and just some simple logic, were able to work out with really high accuracy some of the proportions in regards to the solar system, and just with some basic tools like a cross staff and stuff, I've talked about those before, we can do awesome observations. And most of this astronomical knowledge that we now take for granted was done before satellites, was done with again, some simple instruments, some simple logic, and we've improved on it, no doubt, but the essence of it was there. And so southeast corner is a representation of proportion, southwest corner, we have those proportions now just shift a decimal point, and now we see them in meters. And again, the meter bringing us back to the whole pendulum thing, which gives us the Egyptian royal cubit and these 86,400 seconds per day. And of course, the northwestern corner bringing us 2D and 3D geometry, same proportions, of course, which again, back to the pendulum, back to the meter, and a 2 and a 3-dimensional, so we're thinking cross dimensions. But of course, that is also where the Indus or the Sumerian pendulum cubit, which is ever so slightly longer, also happens to describe the base of a pyramid, including the sockets, as where the Egyptian royal cubit of 0.5236 meters describes the pyramid itself times 440. This one times 440 describes the pyramid including the sockets, and those sockets are vital because we need them to get us that extra little bit of length on the base of a pyramid to bring us to 86,400 as a scaling of the Great Pyramid to the size of the Earth. And so, yeah, just to recap, because the last video I kept saying by accident that it was the northeast corner that represents the Indus cubit. Well, it does, but this one is the more accurate of them all, and it's also relevant because we have this crossover to this other important geometric stuff, and of course that's 1.273, which means the square is 27.3% larger than the circle, which is a tie-in to the previous video, and as well as that unit of 27.3 grams, which was standard in both the Indus and the Old Kingdom, the Devon. And again, in the part 2, I've got a whole bunch of links with sources, citations, and Sumerian weight scales basically comes down to the same grain that they were using in the Indus, so that would cross over, but they were using it on a different scale, as where this one was double, and same with the Egyptian. But again, in part 2, there are lots of citations and sources to go into that. So just some more information, and just to correct I kept saying the northeast corner for the Indus scale, but as you can see, this method and this perspective 3D thinking about the pyramid only keeps confirming my developing theory that each corner and that the pyramid is slightly different on each side for a reason, and that it's painting us a picture. It's a map, and it's like a journey, a textbook in stone. As we move around, you could spend one day talking about this corner and the proportions. Then you move to the southwest corner and you start getting meters, and those same proportional numbers, phi and pi, will also emerge. Then you get into some cool geometry as you move around to this corner, and in this corner we have astronomy in those same proportions, which bring us back to the pendulum. So we have a system that feeds in on itself. And so I hope you enjoyed. Yeah, just to try and recap and just to correct some things. And with that, hope you enjoyed. Cheers, have a good one. Please like, comment, or whatever it is you want to do.